Casper and Brian went to lunch for tacos, and Casper buys 3 tacos and Brian buys 5 tacos. Brian's total was $5.68 more than Casper's total. What was the cost of each taco? So this is a similar idea. So 3 tacos plus 5.68 equals 5 tacos. So why did I put the 5.68 on the side with the 3 tacos? Well, it said that the cost of Brian's was that much more than Casper's total. So I have to add it to the total from the Casper's tacos. So once again, we've already got everything we need. We just need to move the 3t. Minus 3t, minus 3t. And so we have 5.68 equals 2 tacos. And the last step in most of these problems is to divide. So that's gone. And so 5 divided by 2 is 2, would be 16. So 8 for 2.84 per taco. So let's see if that's a number. Yep, and that is H. Now, once again, we could plug that in, and we would see 3 times 284 plus 5.68 equals 5 times 284. So you should try to put that in the calculator on the left side first and then the right side and see if those two values are indeed equivalent. Anna and Aisha are playing games at the arcade. Anna started with $15 on her card, and the game she is playing charges 75 cents per game. Aisha started with $12.75, and the game she's playing is 50 cents per game. If Anna and Aisha played the same number of games and their game cards now have the same balance, how many games did they play? So once again, this is a problem where we just need to write them down and set them equal, because it says that same balance. So that's what I'm looking for. So 15 minus 0.75 per game. Why am I subtracting? Because when you play a game, you're spending money. You're losing that value. And then $12.75 minus 50 cents per game. And the process is the same. Let's move the variables to this side. Let's move the constants to this side. Minus 15, minus 15. Okay, that's gone. 12.75 minus 15 is negative 225. And if I add 0.5g plus 0.5g, I get negative 20.25g. And then lastly, I divide. Remember, dividing by a decimal gets you a larger number. And we know that $2 is 8 quarters. And then that's another one. So $2 is 8 plus 1 is 9. Okay, and we can plug that back in just like before. So 15 minus 0.75 times 9. Okay, so let's check that value. 15 minus 0.75 times 9. And that's 825. So then if we said, well, that's 825, 8.25. We can check the other side. 1275 minus 0.5 times 9. And 0.5 times 9 is, as we've already done, is 4.5. And so that is also 8.25 when I subtract. Okay, so we can always plug it back in to see if we get the values the same on the left and the right. Okay, so let's look at the last problem. 10 packs of tickets for rides at an amusement park sell for $125. One family has already used 2 of their tickets. They now have 9.6 packs left. Which equation can be used to find T, the number of tickets in each package, and what is the value of T that makes the equation true? Okay, so let's look at F and go from there. So 9.6 packets left, and they're saying take away 2 more equals the total 10 packets. Well, I've already taken the 2 away, so if I want to talk about the number of tickets total, I have to add those tickets back. So I have to add the 2 tickets, not take away the 2 tickets. So I'm going to say that one's not right. Okay, now once again, G looks exactly like what we have, so we'll leave G for now. H says 9.6t equals 10t plus 2. So this is saying the 10 packets plus 2 additional tickets equals the 9.6. But we know that it's 10 minus that value gives you the 9.6. So it's not that one. Okay, and so J says that it's 9.6t equals 10t minus 2. So our total minus 2 tickets, which is what happened. So we just need to verify if it's negative 0.8 or positive 5. Now, these are T stands for what? The number of tickets in each package. Can I have a negative value stand for a ticket? No. Tickets are a physical thing. You can't have negative of a physical thing, right? I can't pick up and say, ooh, I've got negative calculators. When I have one in my hand, it doesn't make sense. So that can't be right just on the basis of what T stands for, the number of tickets. So it's got to be G. Now, to test this, all we need to do is put the value in. So 9.6 times 5 plus 2 should equal 10 times 5. Okay, well, we know 10 times 5 is 50. And so we just need to verify 9.6 times 5. So 9.6 times 5 happens to be 48. So 48 plus 2 is 50 equals 50. Well, did the left and right match each other? Yes. So, in this case, we didn't have to actually solve anything. We could just use the answer they gave us and plug it back in without doing any of the solving ourselves.